In this video, I'm going to show you two different ways to determine electron configuration. In doing so, I'm also going to show you how we can use the noble gases to create shortcuts. First, we're going to have this chart, and we're going to use this one. And looking at it, you can see that it's arranged in order, going from left to right and top to bottom. So we start off at the top with 1s, and then below it 2s, and then 2p, and then 3s, 3p, 3d, and so on down the line. One thing that we have to make sure that we memorize is how many electrons each of these orbitals can contain. So s can have up to 2, p can have up to 6, d up to 10, and f up to 14. So as an example, let's find the electron configuration for potassium, which has 19 electrons. And here we're going to use the chart, and the way we're going to use the chart is diagonally. And when we do that, it's going to assure that we fill our electrons in the correct order of the orbitals. All right, so let me show you what I mean by that. We're going to go diagonally in this direction all the time. And 1s is going to be the first orbital that's going to be filled with electrons. And again, s can fill up to 2. And then our next diagonal line is going to go through here. And we're going to fill the 2s with 2 more electrons. And then we're going to go through the 2p. And remember, the p orbitals can fill up to 6, so this is going to have 6 electrons. We continue the diagonal line, and it's going to go through 3s with another 2. So right now we filled 2, 4, plus 6 is 10, and another 2 is 12 electrons. Our next diagonal takes us through 3p, and that's another 6, and that's going to bring us to 18 electrons. So we're only one more away. And so the next orbital with our diagonal line is going to cross through 4s. And we only need one more, so it's not going to be 4s2, it's going to be 4s1. And that's going to make our 19 electrons. So this is the electron configuration for potassium. And you can see how the chart is helpful because it gives us the correct order that electrons fill the different orbitals, or the correct order of orbitals. And it can be very helpful because as you get larger in number, the orbitals fill with kind of a confusing combination. So for instance, this one went from 4d to 5p to 6s. So it's a different energy level number as well as a different orbital letter. All right, but there's an easier way, I think, of doing this because you can see that there's a lot to write there. And so we can do a bit of a shortcut, and that's by using the noble gases. The noble gases. And so let's go back and we'll look at potassium here. Here's potassium. And the rule here is that we're going to use the noble gas that's closest to potassium but has fewer electrons. So we're going to go backwards on the periodic table, and that's going to bring us to argon. Argon, which has 18 electrons. So remember, we stopped here at 18. All right, so this is the electron configuration up to 18 electrons. So that means this set is the electron configuration for argon. Okay, and so we're just going to use that fact and let argon, the symbol AR in brackets, represent everything that we did here. Okay, so instead of writing all this out, we're just going to write argon in parentheses. That's going to represent everything here, and then we just have to write the 4s1. And we have the electron configuration for potassium, but without writing all of this initial stuff and just doing the finishing touches, using the noble gas to represent a lot of the configuration. Okay. Now the problem becomes, all right, here we just, I said, all right, we're going to use this noble gas, and moments before, I just happened to write out the electron configuration up to 18. All right, so I knew that it ended at 3p. And then I can see, oh, the next thing is 4s. But what if you don't have that? All right? What if you just don't know it at the top of your head? Well, that's why when we look at the chart, I have this center column in yellow, color-coded in yellow. And each one of these represents the point where a noble gas finishes. I'm not including helium because helium's so small that it's not really much of a shortcut. But looking at the noble gases, neon fills through 2p, and then argon fills to 3p, krypton fills to 4p, xenon fills to 5p, radon fills to 6p. Okay, so when you're looking at it, looking at this chart, oh, this is, this starts off at neon, and the next one is argon, and it's the next in line, and the next in line. So as an example, let's say that we are finding strontium, let's say, and let me grab a color. Let's go strontium right here, SR, and that's 38. And so again, we find the noble gas that is closest and with fewer electrons. So that is going to be krypton, okay, with 36. So we're going to put krypton here in the brackets to represent the krypton electron configuration. And then we know that it is filling up to 4p, which is here on the chart, right? So that means krypton goes through here, through here, through here, through here, through here, and then it's all filled up. Okay, but we're strontium, we have 38, krypton is 36, so we are going to continue to the 5s, so we know that that's where it's left off, 5s, and we need 2 more to make 38, so it's 5s2, and so this is going to be the electron configuration for strontium. All right, so that's how you use this chart as well as how you use the noble gases. Now, I'm going to show you one more way that I think is extremely beneficial and much easier than using the chart that I just showed you. But it's necessary, I think, because so many classes use it. So I'm going to get rid of the chart and the potassium here because we don't need them any longer. And all we're going to do is use the periodic table. Okay. Now, if you look at the periodic table, you can see that it's color-coded, and there's a reason for that. Looking at it, the light blue represents everything in the S, everything that has s orbitals, right? And then everything in the orange represents all the p orbitals. Everything in yellow represents the d orbitals. And then I cut off, for the sake of space, part of the periodic table, but the bottom of the periodic table would be a different color, and that would represent all of the f orbitals. And taking a closer look, remember that s has 2 electrons in it, or can have 2 electrons in it. Each of those are represented by the 2 columns. So if S has 1, if it's an S1, it's something in the first column. So this column represents the first electron. This column represents the second electrons. P, each of these going across represents one of the 6. So this is P1, P2, P3, P4, P5, and then P6. All right? And then D, that's going to be the same. D1, D2, D3, D4, 5, 6, 7, 8, 9, and D10. All right. And then we can write down the different energy levels. 1, 2, 3, 4, 5, 6, and 7. All right. So now in order to find the electron configuration by just using what we know in this chart, we can do this. Let's say we want to find titanium. You know what? Let's make it a little bit where we'll go chromium. We'll go down a little bit. All right, so this is CR, and it has 24. Just to put that down. All right, so to figure this out using just the periodic table, understand that all of the electrons above it have been filled up to all the way around up to chromium. Okay, so we can say that it filled the 1s orbital, so it filled the helium, the hydrogen and the helium. All right, so it's 1s2, and then it filled the 2s2, and then the 2p, right, and 2p6, and then it filled the 3s2, it filled the 3p6, it filled the 4s2, and then here you'd be it would be logical to say that it's the 4d, but the d orbitals do something strange, and it's easy to remember. Just remember that each d orbital is one less in energy level. So instead of this being a 4d level, this is a 3d. And let me put it in red. This is a 3d, this is 4, this is 5, and this is 6. So instead of 4, it's a 3. Instead of 5, it's a 4. It's one less than the level next to it. Okay. All right. That being said, let's continue. And so we left off at 4s2, and then it's going to be 3d, right? 3d, and then now you just count your spaces to get to chromium. So this is D1, D2, D3, and chromium's at D4. So this would be the full electron configuration for chromium. And I think you can see how much easier that can be instead of looking at the chart and drawing the diagonal lines. Okay, here you just look at the periodic table. You can easily tell what section is S, what section is P, what section is D. You can count off the numbers to the place you want to get to. All right, and so here, now we're going to change this and use the noble gas configuration as well. And we don't need to memorize and look at the chart. We can just look at the periodic table. So here again, chromium, the closest one to chromium is going to be argon, and I don't know, let's try red. Alright, so it's going to be argon right here, because that is the closest one to chromium that has fewer electrons. So it's going to be argon in brackets. Okay, so we're here at argon right now with our configuration here in the red color. Now we have to write out up to chromium. So it fills this area, which is the 4s2, and then it fills this next area here up to chromium. It's going to fill this part right here I'm talking about, and that's going to be the 3d, and again 1, 1, 2, 3, and 4. All right, so again, much shorter, a lot easier, and all we are doing is using the periodic table and understanding each section is going to represent different parts of the electron configuration. All right. Maybe let's do one more. I know the video is getting kind of long. Let's do something way over here. Let's do this. Let's do silicon. No, let's do bromine. Okay, we'll come all the way here. We'll do bromine. All right. So again, the closest noble gas is Krypton, but that has more electrons than bromine. So again, the closest one is going to be Argon again. All right, and then now it's going to be this is going to be 4, so it's going to be 4s2, and then this is going to be 3d10, and then this is, we're going back up to 4, and that's going to be 1, 2, 3, 4, 5. So it's going to be 4p5. Okay, so summary, remember using the PR table, this is the S section, this is the P section, this is the D section, and we number off the energy levels 1, 2, 3, 4, 5, 6, and 7, but then the d orbitals are a little bit different. We go 3, 4, 5, and 6. All right, so I know the video is longer than you're used to on my YouTube channel, but it does, I think the video, just keeping it all in, within the 15 minutes or 16 minutes, giving all this information is going to be useful. All right, do some practice. If you're confused, it'll come to you, and after just a few tries, it'll become much, much easier to figure out electron configuration.